So with that, before we dive into our main presentation with Blake, I would like to first pass it to Andrew Roberts for a few quick intro slides on cStor, and then we'll get going on our main event. Andrew?
Okay, thank you, Kim, and good afternoon, everybody. As Kim said, I am Andrew Roberts, the Chief Cybersecurity Strategist here at cStor. I do see a lot of familiar names out there, but for those of you who may not be familiar with cStor, let me just take a couple of minutes to tell you who we are and what we're about. cStor was founded in 2002 by an engineer, and his mission at that time was really just to solve our clients' problems. And he really focused on two things: doing the right thing and solving those problems. And still today, cStor has more engineers than we do salespeople. We are focused on business outcomes and helping our clients get the right architecture. We take a vendor agnostic approach that always puts our client first. Our solutions offerings are grouped into three main focus areas: data center, where we have our roots, digital transformation, and of course my favorite one, cybersecurity. cStor's cybersecurity practice is very robust. In fact, our entire team is comprised of security practitioners. So we understand where you're coming from and the challenges that you're facing, because we've sat in the same seat that you're sitting in today. We work very hard to help our clients take a more proactive and strategic approach when it comes to cybersecurity. And because of all of this, cybersecurity is the fastest growing part of cStor today. Our mission here at cStor is simple. We put people on the path to success. And that means, not just our people and our partners, but more importantly, our clients. And smart cybersecurity is a way to put people on that path to success. And it's also a way to help maybe you get some more sleep at night. All of that is wrapped up and supported by our services team. And they're there to help you get the things done and done right the first time, so that you can really start enjoying the benefits of those investments that you've made and get back to doing the things that are more important to you. And our services team can take that other mundane stuff off of your plate. So with that, I know that's not what you came here to hear, and certainly you didn't come here to hear me. Let's get into today's session. We've got with us Blake Wood from Thales, who's with us here this afternoon to share some of his great knowledge with us. Blake.
Thank you, Andrew. Welcome everyone. Thank you for coming to the webinar today. Again, my name is Blake Wood, and I am a certified information system security professional and certified cloud security professional from ISC Squared. And I really appreciate companies like cStor that build cybersecurity practices, because I'm telling you, today you need that expertise. The cloud is exploding, the use cases are exploding, and I'm dealing with that every day. I'm a past security practitioner myself, and so I appreciate the efforts that vendors put in to build out the expertise that you, the customer, need to be successful in the cloud. So let's take a look at our agenda topics for this webinar today. Going to touch on a few things: data security and complexity in the cloud. I mentioned the use cases that are exploding, and there's no end in sight to that, which is making the security effort in the cloud even more challenging. The shared cloud security model, again, we don't get to control everything in the cloud, and so it's important to understand what you have to control and how you do that. Then I'm going to go to business risk profiles and strategies for cloud security. Based on what the business risk is, you can choose a different strategy. Some are more expensive and more involved. The cloud would love you to just opt in completely to their security countermeasures, but there may be reasons for you to think about not doing that. Then I'm going to turn to centralized key management and talk about operational sovereignty a little bit. There's the key in the title is a pun that was intended because centralized key management is very important, especially for encryption. And then we're going to talk about the different methods of encrypting data in the cloud. And then lastly, we'll wrap up and take some questions. So the state of data security, I think a lot of anyone that's on the internet, anybody that's in any business, anyone that's doing anything on computers understands the amount of data that we're creating every day. And so that is exploding And again, this data is from over a year ago. 175 zettabytes is what it's going to approach in 2025. It's just on a exponential growth curve right now. A lot of you may have heard about emerging privacy requirements and laws, regulations across the planet, including here in the US, where the federal government hasn't stepped up yet. That might change with this new cybersecurity executive order, but the privacy efforts are being handled by the states here in the US. Operational complexity is growing, especially with the cloud, and it's one of the things that catches people up when they're trying to design out their security for going into the cloud. And then, of course, the data breach issue, which also doesn't have any end in sight. We hear about data breaches every day, and so encrypting your data is a really good idea, especially if you're going to outsource the hosting of it to a third party. And then here's some other factors that are exacerbating the data security problem. The complexity, with only 54% of organizations knowing where their sensitive data is stored. That means almost half of the organizations don't know where their sensitive data is. And that's not, you'd think that might be, a unique problem, but it's not. It seems to be very widespread. When you start rolling out systems, once they're up and running, you tend to forget what's in there. So companies have been around a long time, tend to have a lot of data. They tend to have a lot of sensitive data as well. 43% of sensitive data in the cloud is unencrypted. That's, again, almost half of all the data out there is not encrypted. So, that's leaving your data exposed to prying eyes. I'm not going to bad talk the cloud providers, but there's a trust issue. There's some companies that don't trust cloud providers. And so when you have data exposed in the cloud, that's always going to be a consideration. 50% of all corporate data is stored in the cloud now, and that's obviously growing. I think COVID poured gasoline on that fire last year. We saw a lot of companies, their workforces started working remotely. A lot of companies started cloud first initiatives last year just because they realized, hey, we're saving a lot of money in real estate, or we could. And so they started thinking along the lines of maybe going remote all the time. What that means is more data in the cloud. And then 53% of organizations control the keys to their encrypted data, only 53%. And we'll talk a little bit about the key management issue. Again, that's the key in the key to data security in the cloud. So this is the shared cloud responsibility model. Some of the cloud providers are doing an incredible job marketing to the general public about how secure they are. I think back to Microsoft a couple of years ago when they hired Brad Smith as their chief legal officer, and they started talking about the privacy problem with all the regulations popping up and how they would help protect you. So they promote heavily Azure as a completely secure cloud, and indeed it does have some countermeasures, but there's some things that you're going to want to consider before just handing that off to a third party. So the customer responsibility is in the dark blue, and the provider responsibility is in the light blue. And so for infrastructure as a service, for those of you not familiar with that term, that's tends to be VMs, virtual machines. And that's really the first step to what most organizations do when they shift to the cloud. They take their on-prem servers, they put them into virtual machines, and they push them up to the cloud. In that model, basically, the customer's controlling most everything. The only thing they're not controlling is the hardware. So the cloud provides that hardware platform that you drop the virtual machines on, which are essentially machines and software. And then you're responsible for the operating systems, middleware, any runtime settings, application platform, and code, and the data in those environments. For platform as a service, and again, platform as a service is is customers using cloud native platforms to deploy their applications, whether that's a Kubernetes cluster or some of these platform function environments where you can actually develop code that gets deployed within the platform itself, like the Azure functions. This is where the customer only has to consider being responsible for the data and the applications. Everything else is managed by the cloud provider, including the runtime, middleware, operating system, et cetera. So it's, again, a smaller footprint of what you're responsible for. But here's the one thing that a lot of people forget about, and that's in a SaaS model or a software as a service model, and that includes a lot of things that we're consuming today. You know, Salesforce.com is a SaaS model, SAP has a SaaS model. A lot of applications out there are software as a service. You, the customer, you're still responsible for your data. And I would go as far as saying you're even responsible for the encryption of your data, ensuring that somehow it's protected. The cloud provider may be doing something under the hood, but if it gets breached, it's really, you know, whose fault is that? So very tricky navigating the different security models for the cloud. So this is an interesting thing. I'd love to take credit for this. I can't. This was sourced by one of my work colleagues who's very brilliant and bright and found this. But this is really looking at the workload risk assessment. In other words, organizations will have different workloads in their computing environments, and some tend to be more risky or have more sensitive data than others. And so what this is showing, as I start up in the upper left-hand corner, would be a 20-person cloud-native startup. And what they're doing is they're cobbling together, they're going to market really fast, and they're not really caring about security that much. So in that scenario, their workloads are going to be very low risk. They might have a few medium risk workloads there and maybe some high risk workloads, but the chances of them while they're in sort of skunkworks mode, getting their offering ready to launch, they're not going to have a lot of sensitive customer data. So their profile is what I would consider a lower risk profile. And then as you move to the right, we have an international manufacturer, which is determined to be a medium risk. They have a lot of low risk workloads. Why would you have low risk workloads? Again, not a lot of sensitive data, especially in machine-to-machine types of communications. There's not a lot of personal PII data or PHI data. The data that we consider to be very high risk is personal privacy information or personal health information. Those two areas tend to be the highest risk type of data. But in this scenario, we have, we've added a few very high risk workloads, and we have a whole bunch of low risk workloads, some medium and some high risk. This organization has a medium risk profile. And then down below, we have a globally publicly listed bank, which is, in the financial services industry, a lot of the things they deal with are very sensitive and high risk. And so that's actually the industry that I come from. I come from the payments industry, where we have to adhere to something called PCI, or the payment card industry, a data security standard. And so this is very stringent. It actually dictates what type of encryption you need to use, the fact that you have to understand something about key management and all these things. So in this scenario, you're going to find a lot more high risk or very sensitive workloads. So financial services is always going to be a very high risk area. And so how does that translate into how we handle that for the cloud? As we look at this diagram, if you go to the very far left, what we have is we have data portability going up the y-axis there, and then we have customer control across the x-axis. So down in the low risk workloads that I talked about, you can really opt into cloud native security measures. And what that means, that's opting into the cloud key management systems and the cloud encryption methods. That's perfectly suitable for those low risk workloads. And then as you move to the right, you get into medium risk. And what I would recommend for a medium risk organization would be to bring some element of controlling your keys. And again, I'm talking about something called key management. It's managing the keys that you're going to be using for your encryption. And you want to control that at some level. And one way to control that is something that's called bring your own key. And bring your own key is the ability for you to have a key management system or something called a hardware security module, for those of you that understand the financial services industry. And you can actually generate keys there and use a method to push those keys up into the cloud provider's key management system. This way you actually own the origination of the key and the key lifecycle. You can delete the key off the cloud provider key management system and so on. So bring your own key is a very good strategy, and it provides a great countermeasure for medium risk organizations. As we move to the next box on the right, we're going up the risk profile here. There's something called hold your own key, and this is something that you're not seeing a lot yet. I like this technology. It's fairly new. If you take a look at what Google Cloud Platform is doing, GCP, they've actually come out with something called the External Key Management Service. Okay, and what this lets providers do is integrate to that external key management service, integrate their key management systems, HSMs, what have you, so that the customer can hold a key, and that key will encrypt or wrap the keys that are being used for cloud native purposes up in the cloud provider's key management system. So that way, the cloud provider at no time do they have the ability to hand over the keys to the kingdom, if you will. There's something called subpoena protection, and it's not as prevalent here in the US, but when you get overseas, cloud providers can actually hand over your data. I believe here in the US, they can hand over your keys. So it's really important to protect your keys in the cloud. So hold your own key, another great technology that's emerging to help you become more sovereign. And then the ultimate is at the very far right. For very high risk workloads, we recommend something called external key management and bring your own key. So, or bring your own KMS, I should say. So you're going to bring your own key management system to the cloud, and you're going to bring your own encryption methods to the cloud. And so this way you have complete operational sovereignty. At no point can the cloud provider get to your keys because you're controlling it end to end. So these are the different risk profiles and the different countermeasures for addressing those. So here we go into key management. Again, we want to talk about centralized key management and some of the things we can do with that. Bring your own key, I mentioned. What bring your own key does is it gives you, the customer, partial ownership and control of that key. You can use your on-premise key management system, or I mentioned hardware security modules or HSMs to generate those keys that will live in the cloud KMS. And so it provides for a certain level of protection. There's different methods of doing bring your own key. There's manual methods where you can use scripts to do the cryptography to wrap the keys up, do the key exchange with the cloud provider, and get those keys into the cloud provider KMS. It's not a fun process. Or you could actually use a tool. In this case, what I'm showing is something we call a key broker application. You don't see a lot of those out there yet, but I'm sure they'll be emerging over time as the cloud providers come up with ways for you to become more sovereign and use your own keys in the process. But a key broker will typically talk to your key management system either on-prem, in another cloud, in your own private cloud, or I mentioned hardware security modules, and then it will automate the process of pushing that key into the cloud provider key management system. It also tracks the key management lifecycle, and it allows you to see what you need to do at any given time. For those of you familiar with key management, key rotation, things like that, it's important to know this if you're pushing keys up to the cloud when they need to be retired. Okay, the next key management method, hold your own key. We talked about a little bit. This maintains key ownership and sovereignty to some degree. And I mentioned the Google external key management service, which is starting to emerge and they're starting to promote. Google also has something very similar for Google Workspace called the client-side encryption. And again, this is a hold your own key method where you, the customer, maintain ownership and control of a key that in turn wraps the keys that Google's using to encrypt your data on Google Drive. So again, provides some very strong protection for your data. Microsoft also has something called double key encryption, or DKE, that they've recently come out with, and that's really an answer to Google client-side encryption. It's designed for Office 365, and it allows you to hold a key that you provide, and basically works the same way. So again, this is hold your own key. And then lastly, the completely sovereign way to do this. If you're in a very high risk profile, if you need to have complete control end to end, if you don't want to give the cloud provider a peek at anything, then you can implement bring your own key management system and bring your own encryption. And so this, again, it maintains complete key ownership, control, and sovereignty. Ensures that the customer is always holding the keys. At no time do these keys get passed off to the cloud provider. And when you combine that with bring your own encryption, then you have what we call operational sovereignty. At no point can the third-party cloud provider get in the middle of your operation. So again, this is very strong. Typical key management systems will have a replication feature. So in the diagram that I have here, you've got maybe two different clouds, or you have an on-prem and public cloud, hybrid cloud situation. In that situation, you would have a key management system in one data center and a key management system up in the cloud, and the two would exchange and keep their keys in sync. That way, as you're encrypting data in your different platforms, if you have to fail over, if you have to move data to the other side, you can decrypt it with the same keys on the other side. So again, completely in sync and high availability, and a very sovereign way to do computing in the cloud. So let's talk a little bit about the encryption options for the cloud. What can you actually do to protect your data using encryption technology, and what are the different encryption technologies? And again, as you move to the cloud, you're going to find cloud native countermeasures. A lot of people think that storage level encryption actually protects data. And again, when you're talking about cloud storage, it's basically the same type of encryption that you get if you did full disk encryption on your PC. And so anybody that's done full disk encryption on their PC knows that when the PC boots up, if you're sitting there, you can get to the data and everything's in the clear. That's exactly the way storage level encryption works in the cloud or on storage arrays. So, if you take away anything from this webinar, just remember that storage level encryption, it's a best practice in the cloud, and it's best practice for SAN storage, but it does not protect your data against breach. What it does do is it's meant to be a countermeasure to protect against data leakage in the event that hardware is disposed of and things like that. So it's not a very strong level of protection for data at all. Next, we move on to something called transparent encryption. And transparent encryption, you'll find transparent encryption in certain database products, Microsoft SQL Server, Oracle. They all have native transparent encryption. Hadoop actually has a transparent encryption function as well. And transparent encryption strength varies from place to place. There's a few things that are important to have for a strong transparent encryption solution to consider it to be effective for protecting data at rest. You can use transparent encryption for unstructured data, on file servers, in volumes to protect whole volumes, storage buckets up in the cloud like S3 or Azure Object Storage can be protected with transparent encryption. They also offer their own, which is, again, more akin to storage level encryption. So a good transparent encryption solution will have a high I/O throughput, so you don't take a big hit as the data is encrypted when it's written and decrypted as it's read. It'll be low latency. It'll have the ability to handle large file and volume sizes into the petabytes. And I mentioned the database feature that Microsoft and Oracle have. And then the best solutions, the best transparent encryption solutions will layer that with role-based access controls called RBAC, and also have strong logging. That's really important, is you want to see the activity that's happening as users are accessing files, they're getting access to keys. If there's certain users that haven't been given the privileges in what we call policies in a transparent encryption scenario, they won't be able to actually access the files. They won't be able to decrypt them. And this is actually a good way to protect, believe it or not, against ransomware. Good transparent encryption solutions will also protect down to the process level. So not just roles, but also machine processes. So you can say my database service account can actually access the database, but these other ones can't. So everybody has to come through the front door of the database engine to get to the data. That way you can control it more tightly. You can also do things with transparent encryption like lock out the root. If somebody hacks into your network and they get root access to a machine, you can deny root the ability to decrypt the data. So a very easy to implement way to protect data at rest. And when it's layered, when a solution has role-based, process-based controls in there, it's very strong. And again, you can use this technology to protect big data environments, containers. I mentioned the two cloud services that I know about, S3 and Azure Object Storage. Databases, because most of the databases are file-based, and basically any file on an operating system. So again, you can tell I like transparent encryption. And the reason I like transparent encryption is because I came from the payment space and I worked on application layer encryption, which is really about field level data protection, okay, using encryption. Some of you may be familiar with the term tokenization. Tokenization is another field level protection technology that's slightly different than encryption. And there are no keys involved with tokenization. So we're not going to talk a lot about tokenization today, but just know that tokenization and field level encryption do roughly the same thing. The difference is encryption methods require keys. So it provides a strong protection for structured data, especially databases. You can go into a database and encrypt certain fields in tables. Data warehouses are perhaps the best application for this, because when you start to encrypt things at the field level, the last thing you want to do in a petabyte file is do lots of decryption activity. Again, this is going to add overhead to the process as you encrypt and decrypt. So data warehouses are perfect because typically what you're doing is you're encrypting those those fields of data as they get ingested into the data warehouse. And very rarely do you have to decrypt down to the record layer or record level. So a great technology for protecting data warehouses and data lakes. I mentioned format preserving encryption, something I worked on a lot about 10, 15 years ago. Format preserving encryption, I'll show you a demo in just a second. This little animation's cute, but there's some pros and cons to it. Again, it uses keys. It has to be done at the field level. It presents problems and challenges, for things like key rotation. So, coming from financial services, everybody's pretty much on a 1-year key rotation scale or schedule. And, when you have data that's encrypted at the field level in a petabyte database, how do you change the keys on that? The answer is you don't, okay? So, a lot of companies that are using field level encryption, they're not rotating their keys because they can't. It would take too long. And the other negative, the other con to implementing field level encryption is it requires some level of application integration or database layer integration. In other words, you're going to have to go into a SQL database and actually modify SQL code to call a user-defined function to perform that encryption or decryption activity, or you do it in code, in an actual application code, application server, so on. So it does take time to implement, and sometimes in certain scenarios this can be cost prohibitive. So that's pretty much all the things that I could go over about field level encryption. So here's a little demo. This is what it does. This is a credit card. And as the credit card goes into the encryption process, what you're going to see is it actually keeps the format of the credit card. It just basically scrambles the numbers. And when you talk about things like credit card data, in the credit card world where I come from, you actually only end up encrypting the middle 6 characters. So again, not a lot of the data is getting encrypted. Anyway, very interesting stuff. Field level encryption is typically considered the strongest level of encryption, but again, it comes at a cost when you're talking about the challenges for key rotation and other types of refreshing of the data, and then also requires some level of software integration. So I think that is the last slide I have. Kim, I'm going to hand it back to you.
Awesome. Thank you so much, Blake. Great information and obviously very timely. Just as a reminder, you can post any questions to the questions pane, and we do have a few coming in, and it looks like we've got some time to get through them. So I know you did talk, this question is, why is a centralized key management strategy important? You did touch on that, Blake. Maybe you could expand on that for everyone.
Yeah, a centralized key management is important because, and I see this in practice a lot, especially with storage level encryption. As you get storage arrays, a lot of these storage arrays actually have a built-in key manager. I think in a lot of different scenarios you'll find that. And so what a lot of companies do is they simply turn on that built-in functionality. What they're doing is they're spreading their key management efforts across multiple systems, and so now they don't have really good visibility on what is the state on device number 1 or number 2 from one place, or they have to go and check that individually. So a centralized key management strategy gives you the ability to serve up those keys to devices and software using a key management exchange protocol like something called KMIP, and there are others. But that way you're in charge of the keys. You can see what stage of the life cycle they're on, and then those applications or devices can actually use those keys to do their encryption and decryption activities.
Excellent, thank you. Next question, does storage level encryption provide any level of data protection at all? Again, I know you touched on that a bit more, but if you could elaborate.
Yeah, really, it's most about data leakage. If you've got a storage array, if you have your own data center, and you had a drive go bad and you disposed of it, in theory, somebody could get a hold of that drive and pull the data off there and maybe have a piece of your data puzzle. When you're using storage level encryption, they can't do that. It's essentially what they call crypto shredded. So all of that information on there is gobbledygook. So it does provide some level of protection, but only in the case of someone stealing a disk or you throwing it out.
Excellent, thank you. Just checking the time. We definitely have time for a few more, and there are a few more coming in. Are field level encryption and tokenization the same thing? Again, you had mentioned that, but maybe you could dive into that a bit more for us.
Yeah, they're not the same thing. However, I know of certain companies that refer to format preserving encryption as tokenization, which I don't. I try not to. So in a perfect world, tokenization methods are based on random data. In other words, you create some sort of table that's randomly created, and then you pick the values out of that table, corresponding to the letters or numerical characters or whatever. And so what happens is you get the same characters back for a character swap. In other words, if you take my name Blake, B-L-A-K-E, as you, maybe B gets scrambled to N and L gets scrambled to I, but each time those characters will come back as you build the string of characters from the tokenization table. When you use something like format preserving encryption, it's based on a block cipher. And what happens in a block cipher is if you encrypt the letter B, it's going to start with something different than if you encrypt the whole string Blake. So the first letter is always going to be different in an encryption scenario versus a tokenization scenario, and that can present some application challenges sometimes.
Great, thank you. Next question, why would you bring your own KMS to the cloud?
Yeah, that's a great question. Again, that's going to be for the most sensitive workloads for companies that have a high risk profile. It gives you the most sovereignty, and again, it comes at a cost. When you take a look at the cloud, it costs literally pennies to use the cloud key management system, and so it's very attractive, especially if you don't know what your risk profile is. But yeah, bring your own KMS, bring your own key management system to the cloud. Will ensure that you can control the keys for all your operations end to end, and the cloud provider will never have it. So that would be I think Google even wrote a paper on that. I was surprised to see that coming from a cloud provider, but I don't know if they put it under the heading of sovereignty or not. But if you guys browse the Google, some of the Google content, they had written something specifically about bringing your own KMS if you have sensitive enough data.
Excellent, thank you. One more question. What's the difference between BYOK and HYOK?
Yeah, that's a great question. Bring your own key is really about generating the key, having some level of control, and then handing off that key to the cloud providers so that they can put it in their key management system. And the cloud providers, most of the cloud providers actually have a delineation of when that happens. So they know when it's a customer provided key versus their own native generated keys and whatnot. So it gives you the ability to pull that key back if you need to cut and run, so to speak. But it does give you some control. But it does expose you as well, because the cloud provider has that in their KMS. Withhold your own key. remember the customers got that key, and that key is being used to encrypt the keys that are in the cloud provider's KMS for cloud native operations. So at no time will the cloud provider have the ability to unlock your data in a hold your own key scenario.
Excellent, thank you. We do have one more question so far. Again, you can post them still to the questions pane if there are more coming to mind. One more question. What are some of the top key systems? I would imagine they're maybe also looking for priorities on how they would evaluate one over the other. Can you speak to that, Blake?
Sure. There's a lot of key management systems out there. There are key management appliances, hardware appliances. There's key managers that are software platforms. A company called HashiCorp has basically taken over the DevOps world of key management by providing very robust APIs for doing key management. But I think what's most important for a key management system is the ability to back it with what I call hardware security module. What a hardware security module does is it holds keys that no one can get to. Nobody can get them in the clear because they're in hardware. And so if you have a key management system that has, again, the key management appliances that I spoke about, they're hardened already. They have this hardware security feature in them, and they're very secure. Performance is another thing you want to look at. You want to be able to, if depending on your application, if you're accessing a lot of keys in real time and doing things. I worked on a system in the payment industry where we had to support, doing somewhere in the neighborhood of 1,000 transactions per second, and each one of those transactions were done by a unique, POS terminal that had a unique key. And so you're literally pulling or deriving 1,000 keys per second. And so there's the performance consideration, there's the security consideration, and to me, there's a lot of vendors out there. Thales is who I work for. I give them a little pitch there. Others are, I mentioned HashiCorp, Udemako, some of our competitors, Entrust. There's a lot of providers out there. And again, the clouds. All the clouds have their own KMS as well.
Great, thank you. That actually concludes the Q&A for today. Thank you so much, Blake. Great information.
Yeah, it's been my pleasure.
And thank you so much. The expertise is again very timely. And thanks everyone for your time and attention today, and to Blake for some great insight. Before we let you go today, I would like to pass it back to Andrew Roberts of cStor for a few closing thoughts and some information on other upcoming cybersecurity events. Andrew?
Yeah, thanks, Kim. And Blake, thank you for spending some time with us this afternoon. I really appreciate it. Really good, informative information there for us. And for everybody in the audience, don't forget, this is just the first in our cybersecurity series. We do intend this entire series to be very educational, and hopefully you'll be able to learn something from everyone. You can see the dates of the upcoming ones on the screen, and all you need to do to register is go to cStor.com/events to register for each one of those. And with that, we can close it out. Thank you, everybody.